Okay, I wanted to give you guys a quick how to do this example of, I'll do an example and then I'll do number 4. So thermostoic geometry, after this, you'll never see stoic again. It'll be done. But we have to do the last bit, which is the same ideas as before, only instead of starting from, say, grams and going to grams of something else, we're determining how much heat will be released or absorbed. So in the example problem I laid out, you have peroxide, 2H2O2 becoming 2H2 plus 1O2 and a delta H of negative 190 kilojoules. Right? So the question asks, if we start with 1 gram of peroxide, how many kilojoules of heat will be released? So I'm going to set it up like normal. First thing I need to do is go to moles. So I'm going to do that. 1 mole. The oxygen is 16 per, and there's 2 of them, 32. And then hydrogen is 1 per, there's 2 of those, so 34 grams H2O2 per mole H2O2. Right? Grams is going to cancel. And then we'll have the other step, because there's only 2 steps this time. Marker is going bad on me. Go to the school and get some more. We go for every 2 moles of H2O2. We have negative 190 kilojoules of heat. So then we cancel out our moles. 1 gram divided by 34 grams per mole times negative 190 divided by 2 would give me my overall answer. I got negative 2.79 kilojoules, which rounds to 2.8. The proper sig figs, because this was 1.0. Okay? Not too bad. It's the same stuff that we did before, only now we're going to kilojoules. And now there's fewer steps. I also want to do number 4. That will leave y'all with 5 problems, all structured the same way for y'all to do by yourselves. You know, on your tables with markers, as I'm sure you can do it. Probably not, actually. So in this one, we have sulfur dioxide. And sulfur dioxide plus O2, looks like there's 2 of these. Is becoming SO3. So that's a really small 3. And this is delta H. Negative 99.1. So we're starting with 74.6 grams of SO2. What did I just say? 6.6? 0.6 grams SO2. Go to moles with the periodic table. So oxygen is 16, and there's 2 of them, so 32. S is also 32. So 64 grams SO2 per 1 mole. Grams of SO2 cancels out. On the next whiteboard, we'll then have 2 moles of SO2 per negative 99.1 kilojoules. That should say kilojoules. And my moles SO2 is going to cancel out. 74.6 divided by 64 times negative 99.1 divided by 2. Let's pop it in the calculator. $74.6 divided by 64 times negative 99.1 divided by 2. 99.1 sounds like a radio station. And I get negative 57.7 kilojoules. That is pretty straightforward. They should all be structured the same way. Hopefully you guys won't have too much of a problem. On Wednesday, we'll have a talk it through, and we'll see where you guys are at then. Hold it.